Hello dear students, hope you are fine and safe at home, and I hope that you could have understood all the videos I have uploaded so far. So today we are going to discuss a new topic, that is conservation of linear momentum. Okay. So what is meant by this word conservation? You might have heard this word in so many aspects, right? Conservation of water, conservation of energy, conservation of forest. What does it mean? It is nothing but we are saving something, right? We are conserving, that is we are that is called as conservation. You might have studied what is conservation of energy, right? What is conservation of energy? It can be neither be created nor be destroyed. உருவாக்கவும் முடியாது, destroy பண்ணவும் முடியாது. Such a kind of energy, we will call it as conservation of energy. Similarly, what is conservation of linear momentum? It cannot be formed, or it cannot be created, or it cannot be destroyed. Initially, whatever it may be, it will be at the end also. Okay? எது எப்படி இருக்குதோ அது அப்படியே இருக்கும், மாறாது அப்படிங்கிறது தான் conservation, right? So conservation of linear momentum means momentum will be same initially and also finally. ஒரு phenomena start பண்ணும்போது என்ன linear momentum இருந்துச்சோ, it will be at the end of that phenomena also. So that is called as conservation of linear momentum. Why we are studying seriously about this conservation of linear momentum? What is the reason behind that? Because whenever we solve problems related to that forces, instead of applying the force formula, we can easily apply the linear momentum. Okay, because force and linear momentum are related by this, right? F is equal to del P by del T. We have already studied. Force and linear momentum are related by this. So when we apply the linear momentum formula, it is easier for us for all the calculations, so that we are deeply studying about this. Okay. So let us see what this conservation of linear momentum says. Okay. In the absence of external force, the algebraic sum of momentum after collision is numerically equal to the algebraic sum of momentum before collision. What does it say? So first point is, in the absence of external force, we are not applying any external force. This is very important. Okay, linear momentum is conserved when it is conserved only if there is no external force. Okay, the algebraic sum of momentum after collision, அதாவது ஒரு collision, what does means? Collision means மோதுறது, இல்லையா? Here they are representing a phenomena, that is collision. Whatever the phenomena may be, we can take whatever the phenomena may be, initial and the final momentum will be equal. That is algebraic sum of the initial momentum equal to sum of the final momentum. Okay, so that is called as linear momentum. Okay, so they have here they have mentioned about collision. Whatever the phenomena, the linear momentum is conserved. What is the condition? If there is no external force. That is very important. If the external force is not there, it happens. Okay, let us see through an example. Consider we can consider this as two ball. Okay, one ball with mass m1 and the another ball with mass m2. Let us take this ball as A and this ball as B. Okay, both the balls are moving. Okay, rendu ball enna agudhu, it is moving. Okay, so after some time their velocities, அது மூவ் ஆகும்போது என்ன கான்ஸ்டன்ட் ஸ்பீட்ல ஓடுது அப்படின்னா u1 and u2 அப்படிங்கிற velocityல they are moving. Consider two balls. After some time what happens? Both the balls are hitting each other, that is colliding with each other. ரெண்டு ஒண்ணுக்கொண்ணு மோதுது. Okay, so when two bodies hit each other, what happens? In the last video I have explained what happens. According to Newton's law, what happens? This body will exert a force on this one. இது மேல ஒரு force உருவாக்கும். Similarly, reaction, right? If a force is there, there will be a counter force, right? So this body will exert a force on this body A. A is exerting on B, B is exerting on A. Okay, so ரெண்டு மோதுனதுக்கு அப்புறமா திரும்ப என்ன ஆகுது? They are moving with that is different velocity. This body is moving. இப்ப velocity is changing. மோதுனதுக்கு அப்புறம் either இது slow down ஆகும் இல்ல fast ஆ போகும், இல்லையா? So முதல்ல இருந்த ஸ்பீட்ல அது போகாது. Okay, so after colliding they are moving with various velocities v1 and v2. So this is our initial velocity, முதல்ல இருந்த velocity. Hit ஆனதுக்கு அப்புறமா உள்ள velocity. Let us take it as final velocity. Okay, now observation or calculation. Okay, I told you that when this body hits on this body, in the body பெரிய ball இந்த குட்டி ball மோதும் போது அந்த குட்டி ball மேல ஒரு force exert ஆகும் இல்லையா? So force on B by A, இந்த B மேல உருவாகுற force எதனால? Due to A. Okay, that is given as, we know the relation, that is what? Del P by del T or del P by T. What is del P? Change in velocity, mv minus mu. You have already studied, right? You are substituting that formula. Since we are taking in the mass nala idhula produce ana force இல்லையா? Mass 1 nala. So m1, இது என்ன velocity? இதோட final velocity என்ன? v1. Mass m1 ஓட final velocity v1 minus initial velocity u1. புரியுதா? So m1 into v1 minus u1. Change in velocity. Del P means change in momentum. Momentum தோட difference. Final க்கும் initial க்கும் உள்ள difference. So first body நால இதுல produce ஆகும். So m1 v1 minus u1 by t. Okay. Similarly, this small ball will exert a force on the big ball, right? Force on A by B. So that is also equal to m into, that is change in momentum. Change in momentum na mv2 minus m2u2. Okay, divided by t. We also know that when these two bodies hit each other, the force exerting will be equal and opposite. Rendu equal but opposite in direction. Okay. So we know that FA is equal to minus FB. FA யும் FB யும் equal ஆ தான் இருக்கும். ஆனா ஒரே difference என்ன? அதோட direction opposite direction ல இருக்கும். Okay, FA equal to minus FB. Now we know what is FA and what is FB. Substitute it. Okay, substitute the value. And you can see here both the denominators are same. So we can cancel the denominator and we can write m2v2 minus m2u2 equal to m1v1 minus m1u1. Okay. Now I have just expanded. Now bring the initial velocities to one term. U term over side. Final velocity to the other side. Okay. That is when you bring this one over here, what you will get? m1 u1 minus m2 u2. Okay, we are taking this one to this side, so here it is minus m2 u2. When this comes over here, minus m1 u1. Okay, sorry, I have not returned the sign as minus. Okay, since it is fa equal to minus fb, here this will become minus. So minus m1 v1 minus of minus plus m1 u1. Okay, so when I take this, I can take the v term to this side. So m2 v2, when this comes over here, okay, m1 v1 equal to, here what is it? m1 u1, and this goes to here m2 u2. Okay, now we can see this is the algebraic sum of, okay, sum of in the momentum. This is the final velocity. So this is final momentum. The algebraic sum of final momentum is equal to the algebraic sum of initial momentum. Understood? Algebraic sum of final momentum is equal to the algebraic sum of initial momentum. So that is called as conservation of linear momentum. Also, there is no external force acting on the body. Okay, this is the condition, and this finally we have proved. m2v2 plus m1v1 equal to m1u1 plus m2u2. Hope you can understood this concept, what is conservation of linear momentum. Thank you for watching.